Okay, so we're going to be practicing a couple of these problems together here, so that we're going to be practicing a couple of your problems here from your work lesson. People have been having a little bit of difficulty with them. I think maybe the difficulty is coming. We need to know what the formula is to determine the amount of work done. Also, it depends on whether you're using English units or you are using, like you could be using English units here, feet and pound, or you could be using metric units, which are newtons and meters. So the force, if you're using English units, would be pounds of force pushing something. If you're talking about force, but we were using metric units, we'd be using newtons. Now, if we were back with the English here, we were using distance, we would be using feet. Whereas if we were using metric units, we'd be using meters, like a meter stick. Okay, so the first and the second problem that you have, the first one is there's a cart. Evidently that they are, the force needed to push this probably on a, I think it's on a roller coaster. The force needed to push this roller coaster all the way up to the top. And they tell us that the distance from the bottom here that it needs to push it up to the top is 120 feet. So the way you would do this is by, looking at this formula here, work equals force times distance. One thing you might notice here that I could have a force pushing on a rock. I could be pushing on a rock as hard as I want. I could be putting 150 pounds of pressure on it. But if, I'm trying to move it. But if I don't move it a certain distance, I have not done any work in the scientific definition of work. I may be sweating and I may be tired, but if I haven't been able to use my force to move that rock a certain distance, by definition, I haven't done any work. So we have to have a force, and we have to actually have an object move a distance for us to say that some work has been done. So we usually use the letter W for work, and F for force, and D for distance. So work will equal force times distance. So let's go ahead and do this problem maybe here first. So the amount of force that it takes to take this roller coaster cart and get it all the way to the top, I'm going to incorporate that force with the distance that I actually get it to go from here to here, and I'm going to multiply them together, and I'll be able to determine how much work was done in getting that cart all the way to the top of this roller coaster. So if the force needed was 350 pounds, and I needed to push it 120 feet up, so it'd be 120 feet from here straight up. The way I determine how much work was done is I just multiply them, and I actually come out with 42,000 foot-pounds. We don't call them pound-feet. We use the foot first and the pound second. So for this particular instance right here, 42,000 foot-pounds of work has been done. Now, instead of using the English units here, let's see if I can get rid of that one arrow. I don't know why I can't get rid of that one arrow there. Let's come over here and we'll do a problem using metric units. So our force this time will be measured in newtons, and the distance that this is a whale. I'm not an artist in any stretch of the imagination, but I think we could probably tell it looks like a whale. So the amount of force that this whale needs to jump up 10 meters, they want to know how much work was done. So again, we're going to use this formula, work equals force times distance, and I'll come down here. And in this case, the distance that this whale jumps, they tell me, is 10 meters, so that's how high he's able to jump. And the force needed for him to jump that high is 800 newtons. So how much work was actually done? So I'll go ahead and put it into my formula. Work equals 10 meters times 800 newtons, and the amount of work done was actually 8,000 newton meters. Now, the trick being in this question is that that's how much work was done for one jump. But now they ask us if he jumped 4 times, how much work was done. So since I calculated the amount of work done for one jump, what would I need to do next? I would need to multiply the amount of work done in one jump times 4. So it would be 4 times 8,000 Newton meters, and I would then get 32,000 Newton meters. So that's how much work he used to jump 4 times a height of 10 meters if he had to use a force of 800 newtons to do it each time. So I hope this makes sense. You have 2 more problems after this one in your assignment to do. It would be a good idea for you to try them on your own and see if you can use, the formula here for work. You need to remember that work equals force times distance. And you would need to remember, if they ask you, if you are maybe pushing on something and you could not get it to move, have you done any work? And by the scientific definition, no, you would not have, because for work to have been accomplished, you have to have a force and you have to move an object a certain distance. So go ahead and give those other ones a try. If you get stuck, we can certainly work on those together. And when you finish with this, go ahead and give me a call so that I can give you credit. We'll discuss the problems a little bit. I'll make sure that you understand the formula. It's not a quiz, but that way I can then give you credit for having watched this video, and we can put the points in for this particular project. So thanks for watching. I hope it helped, and I'll be looking forward to talking with you soon. Okay, bye-bye.